China has allegedly developed a new, cheaper, more fuel-efficient drone turbofan engine that it hopes it can mass-produce to make cheaper drones, stepping ahead in the drone race. Chinese researchers have successfully developed a new low-cost jet engine which, it is claimed, costs less than 20% of most other machines. These new engines are now being used by the People's Liberation Army to roll out large numbers of low-cost, high-speed, long-endurance drones. This could enable China to effectively bankrupt opponents attempting to match China like for like in drone numbers. And herein lies the true strategic benefit of these new engines. For example, Northrop Grumman RQ-4 Global Hawk uncrewed aerial vehicles have a Rolls-Royce AE 3007 turbofan engine, which each cost around $4 million apiece. And that is before the expenses incurred for regular services and repairs further elevate the overall cost of these engines. If China can now produce considerably cheaper and relatively parable UAV units, the escalating costs of building many Global Hawks or other drones would quickly become prohibitive, especially in light of the U.S. recently announcing plans for its Replicator program. While this program is explicitly designed to produce cheap drones if we cannot find more frugal engines, this Achilles heel is something China hopes to exploit with its new economical turbofan engines, explained Zhu Zhengkang, a Chinese engineering thermal physicist. The war of drones will be a war of money. What's also interesting is that China has managed to achieve this, considering it's a relative newcomer to the jet engine technology sector. Only recently did its G-20 stealth fighter receive a pair of domestically produced engines. Regarding the new engine, its secret sauce is its relative simplicity in design compared to other turbofans. We built the world's first compact turbofan engine with a single shaft. Most of the turbofan engines that are currently in use have multiple shafts for power transmission. This is because the smaller fans located in the front of the engine, which compress the air, need to rotate at a higher speed than the bigger fans located at the rear, which generate the thrust. The Global Hawk's turbofan uses a sophisticated gearbox connecting two shafts, and if the gears bite and lock the shafts into one piece, the drone may rapidly lose altitude. In China's single-shaft turbofan engine, the airflow follows a unique path through saxophone-shaped ducts. Unlike other engines, which have a straight way from front to end, this design enables the air compressing and thrust-generating fans to spin simultaneously. As a result, all the fans can be connected with a single shaft. Militaries do not only consider the price of an engine while making a purchase decision, they also take into account the overall performance and ease of servicing. Furthermore, they prefer machines with a design similar to their existing models. But that's not the only benefit of the new Chinese turbofans. It consumes nearly a third less fuel than the previous two-shaft engines, and its maintenance costs are significantly lower because it has 70% fewer mechanical components. Combining these factors, the new machines cost around 80% less than alternative, more conventional ones. This is very remarkable. Currently constructing a facility equivalent to 24 football fields in size. The primary purpose of the facility is to aid the development of next-gen drones. The facility will simulate the challenging flight conditions of Mach 6 on the ground. Researchers will also utilize a large X-ray machine to study the hidden structural alterations of the engine and drone during the ground tests to help them gain new insights to enhance the performance and minimize the cost.